everybody, I'm meteorologist Gavin Sandel. A quick look at the weather map reveals several streaks of colors all across the landscape. These streaks are known as fronts and can trigger some very familiar weather in our area. So let's break them down. Fronts are actually boundaries of air masses between one and another, and their characteristics can differ. Temperatures, winds, and humidity can all be different on one side of a front and another. And two of these fronts that we really know and are in our area is a warm front and a cold front. So let's break these two fronts down. This is a low pressure system, a mature one in that act in our area. And the warm front is designated as a red one right here with semicircles, and these semicircles point to the direction where that warm air is going, so towards the north, and they typically go poleward. The same story can be told for cold fronts as well. These triangles point in the direction where that cold air is going, and that tends to go east to west, or west to east as well. And just based on the dynamics of how these fronts run, the cold front actually goes quicker than the warm front, and that will have a pretty big impact later on. So let's now get into a cross-section of what happens just to get you a better understanding as well. Warm fronts, the lift is more gradual. You can see that slope is much less. The warm air is going in the same direction as the cold air, and so you tend to have over towards the right side, you can tend to have more of that cirriform, those high clouds, because there isn't a lot of moisture. But once you get closer to that boundary, once there's more air being lifted up, you can tend to have very low clouds and some steady rain as well. That's a big characteristic of once you're about to get past from a warm front. In here, in between these two fronts, that's called the warm sector, and that is characterized by high temperatures, high humidity, but generally nice conditions. But look at how this is just sloped up here, and that means that there's a lot of lift when you get to a cold front, and this is a very big area for thunderstorm development. If it's unstable, you can have severe thunderstorms. That's one of the #1 causes for thunderstorms, especially in the spring and early summer seasons. So just I'm going to put some colors up and some conditions up as well so you could see. Once it's nice, very far away from the warm front, it starts to get a little more inclement. The warm sector is pretty nice, but then once you get to the cold front, that's when a lot of lift happens and you get pretty strong rain and storm activity. And once you get past that, though, it is a crazy, just sharp snap of the finger. Temperatures and dew points go down and conditions get much, much nicer. But like I said, cold fronts move much quicker than warm fronts. So if a cold front catches up to a warm front, it overtakes it, and you can see at the bottom, there's no warm air at the surface. It's all cold air. And so what we do is we name this a different front. It's called an occluded front, and we designate that in purple color. And you can see on a map right behind me, this occluded front is, you kind of combine the warm and the cold front, their appearances. You include both the semicircles and the triangles as well, and this can spell the end of a low pressure system because now you're getting rid of that warm air to try and fuel the low pressure system. So this is typically the last stage in their development. But those aren't the only fronts that we talk about here. This is one that we can see in our area during the summer, but is also very prevalent in the tropics. This is a stationary front, and it also divides cold air and warm air and other conditions as well, but just neither air mass can overpower each other, so it just kind of stagnates right there. And typically you have inclement conditions over a long period of time if you're near that front. This one right here, this yellow one, you might have not seen. This is a dry line, which can typically form in the southern plains. And unlike temperatures typically, it actually delineates the boundary between moisture. So you could tell in this area, pretty moist air comes from the Gulf, and you can have just stagnant dry air, and so this can also be a threat for thunderstorm development as well. So while we don't experience dry lines around here, the others, warm, cold, and the rest of the gang, are all the cause of active, unsettled weather around the valley. For Weather 101, I'm Gavin Sandel.